Well, for all of you guys that are going to go on to calculus, starting from here, we're learning about some really important things that involve trig. It's all about these things called identities. It's kind of, back when we did logs and exponents, that we learned all the different traits that we could do of like log. We did the expansions of logs, we did the compressions of logs. With exponents, we learned, basically how to add exponents, when to subtract them, and all that. Well, this is where we're kind of learning on how to manipulate some of our trig functions. And so this is starting in this lesson. And like I said, everything we learn from here on out is very, very, very important, especially for you guys going on to calculus. All right, first thing that we learned was this really in this lesson. Hopefully, y'all go back and read through everything, all those that list of identities. You have to know all of these identities. There's no way you're going to be given a card and you can write them all down. You actually have to know these, which they kind of make sense when you look at them. Like coming up here to that list, if you can just remember this one right here that I starred, this number 6, the sine squared and cosine squared equals 1. Remember, and just pay attention to how I formed this, which is just using Pythagorean's theorem, where of this right triangle right here, where x is cosine theta, that's something we know, y's are sine theta, that forms that. And then right here on this note, that's really on how you get 7 and 8. So really make sure you read closely through this whole bottom part right here, and it develops 3 of our trig identities, and you don't have to memorize them. If you understand, if you just remember the first one, sine squared and cosine squared always equals 1, no matter what your angle is, then the other two just come nice and easy by just looking at the note down here. Okay, so let's go off into our first example. And in this first example, what they want us to do is to find if our x value is 5/13, where theta is in quadrant 4, we want to find the sine value. Okay, well, what we need to do is find an equation that can relate sine and cosine together, and that's really one of our first primary ones, our identities, which is sine squared theta plus cosine squared theta equals 1. Or we can see it as sine of theta is equal to, move that over, 1 minus cosine squared theta. That was squared. So if we want to get rid of the square, we take the square root, put plus or minus. So sine of theta is plus or minus the square root of 1 minus cosine squared theta. Okay, and notice where I put the squares. They are right there next to, it's sine squared. It's not sine theta squared. It's sine squared. You're kind of squaring your function, not necessarily your angle itself. Okay, now in here, what this is basically saying right here is if I want to find sine theta and I know cosine theta, just plug this in and we can find sine. So sine of theta is plus or minus the square root of 1 minus my cosine theta. Well, cosine theta is 5/13, so I'm going to plug in 5/13, and since this says cosine squared, I'm going to square 5/13. So sine of theta is plus or minus the square root of 1 minus 5 squared is 25, 13 squared is 169, and then we just have to finish cleaning this up. So sine of theta is plus or minus, let's see, 169 minus 25 over 169. So sine of theta is plus or minus the square root of 144 over 169. And sine of theta is plus or minus 12/13. Now we don't want both plus or minus, and this is the only part where this thing here in quadrant 4. If cosine is 5/13 and our angle is in quadrant 4, let's find sine. Well, sine has to deal with the y values. So in quadrant 4, are my y values positive or my y values negative? Well, we're below the x-axis, so my y values are negative. So really, my answer is not this plus or minus. My answer is just negative 12/13. We can box that up and call this problem done. So let's go on to our next one. Okay, it says if cosecant is negative 17/15 and x is in quadrant 3, we want to find cotangent. So we want to know, is there a quick relationship between cotangent and cosecant? Well, we know that cotangent squared x plus 1 is equal to cosecant squared x. And the problem asks us to find cotangent, so we're going to move the 1 over. So cotangent squared x is equal to cosecant squared x minus 1. Let's take the square root, and cotangent x is equal to plus or minus the square root of our cosecant squared x value minus 1. So cotangent x is equal to plus or minus my cosecant x value, which is negative 17 over 15 squared minus 1. So cotangent x is equal to plus or minus the square root. Negative 17 squared is 289. 15 squared is 225 minus 1. So cotangent x is plus or minus the square root of 289 minus 225 over 225. So cotangent of x is equal to plus or minus 225 to 289 looks like 64. So the square root of 64 over 225. And cotangent x is going to be plus or minus the square root of 64, which is 8, of 225 is 15. And like what we did in the last problem right above this, we need to figure out, do we go with plus or do we go with the minus? Well, if our angle, which is x, is in quadrant 3, cotangent, which is the ratio of x to y's, are positives, so we want to go with positive. So cotangent x is just 8/15. We can circle that one and call that one done. Okay, so let's go to this next one. We want to see that if we know that cotangent is negative 3 and our angle is in quadrant 4, let's find cosine. So is there any direct relationship between cosine and cotangent? Not quite directly like we've been able to do before, but here, let me scroll up just for a second. If you look at this formula right here, I know cotangent. This can find cosecant. If I take the which the reciprocal of cosecant is sine, and then maybe we can connect sine to cosine. Let's try that. Or let me do this for you. Let me try out these two formulas. We have tangent squared t plus 1 is equal to secant squared t, or we can use cotangent squared t plus 1 is equal to cosecant squared t. Okay, so like I said, we could plug in this that we know. That'll give us cosecant, the reciprocal of cosecant sine, and we can get cosine off the sine without too much problem. Or, let me think here. If we try this first one, this top one, do I know tangent if I know cotangent? Well, the relationship between cotangent and tangents are reciprocals. So this could also tell me that tangent of t is the reciprocal of negative 3, which is negative 1/3. And if I know tangent of t, it can give me secant, and secant is the reciprocal of cosine. So now that I'm thinking about it, why don't we just go with this first one right here? It'll be one step faster at least. Okay? So if we go with tangent squared t plus 1 is secant squared t, then tangent is a negative 1/3. It tells us to square it. Plus 1 is secant squared t. So 1/9 plus 1 is secant squared t. 1/9 plus 9/9 gives us 10/9 is secant squared t. Okay, well we want to get just secant by itself, so take a square root and do plus or minus. So plus or minus the square root of 10 over 3, so the square root of 9 is 3, is going to be secant t. Well, the reciprocal of secant is cosine, and if I take the reciprocal of the right side, let's take the reciprocal of the left side. And there you go. So now cosine is either going to be plus or minus this 3 over the square root of 10. In quadrant 4, my cosine value is to the right of the y-axis, so we're going to go positive. So cosine of t is 3 over the square root of 10. Let's just finish rationalizing this out so we don't have any radicals down there. and cosine of t is 3 square roots of 10 over 10. We can circle that up and call our problem done. You would have gotten the exact same way had I started out with the one I was initially thinking, but then realizing we actually had a little bit shorter one, but you would have gotten the exact same answer. Okay? All right, let's go to this next one. Before I scroll down, I'm going to keep these other two up here so we can look at them if we have to. We know cosine. Cosine's a negative 2/3, and we want to find cosecant. Okay. If we know cosine, probably not going to use either one of those two, so I'm going to go ahead and finish scrolling down. So that thought just popped in my head. That I know that cosine squared theta plus sine squared theta equals 1. I know this guy right here. If I plug in negative 2/3 into here, it's going to give me sine. If I find sine, take the reciprocal, I get cosecant, and we can call it done. So let's go with this one. So negative 2/3 squared plus sine squared equals 1. 4/9 plus sine squared theta is equal to 1. Let's move the 4/9 over. So sine squared theta is 1 minus 4/9. Or sine squared theta, 9 over 9 minus 4 over 9 is 5/9. Let's take our square roots plus or minuses. So sine of theta is plus or minus the square root of 5 over the square root of 9, which is 3. Again, we want to find cosecant, so if I take the reciprocal of the left side, the reciprocal of sine is cosecant. The reciprocal of square root of 5 over 3 is 3 over the square root of 5. In quadrant 2, are my y values positive or are my y values negative? Well, we're above the x-axis, so we're going to go positive again. So cosecant of theta is 3 over the square root of 5. Let's rationalize this denominator. 3 square roots of 5 over 5. And box this up, and we can call this one done.